Welcome to Faith and Science. I'm Dr. John Ashton. It still really amazes me that in so many of our Western countries in particular, we are not in our schools teaching our young people the evidence for a creator God, or even the evidence for intelligent design. Instead, we're teaching our young people that we're evolved and we're by random chance, blind mutations to some sort of molecular structures that formed randomly. So to me, it's very empty in life, and it leads to a focus on for people to focus on, well, I might as well just get out of life what I can, rather than there is a overwhelming evidence for a creator, an amazing creator. And of course we have the supernatural evidence and the inspiration of the Bible that describes that this creator is a loving being, and he's created us in his image so that we can actually have a relationship with him. And this is what he desires, and how originally God actually walked with man, but as a result of man choosing evil and disobedience, God separated himself. And it makes so much sense, but also we have the amazing story of reconciliation where God himself came and lived among us as a man again. In other words, walked among us again, but in a very humble way, as Jesus to teach us. And then, of course, Jesus was put to death, and that was God. So it's amazing that God's the beings that he created actually tried to, in actual fact, kill him. But of course he resurrected himself. And of course it's a beautiful story, and it makes a lot of sense when you read it in detail. And that's why I'd like to really encourage readers to read in particular the New Testament of the Bible, which contains the eyewitness accounts of the people that actually walked with Jesus, who was God, what he taught, how he taught that he was God, and who with him saw the miracles that he performed, where he restored the sight in blind people, he healed lame people, he raised people who had been dead for several days back to life, and then himself raised himself after death, and supernaturally transformed himself back and went to heaven. And these are eyewitness accounts of the people. And, of course, that's why Christianity spread so quickly against the paganism and even powerful persecution that tried to stop it back in the first few centuries AD. So we have this powerful account, and it makes so much sense. And one of the amazing things, of course, too, is that a whole lot of factors were actually prophesied hundreds of years before. And God described and revealed and said, look, I'm going to reveal the future so that you know that it is real, that I am real. But for me as a scientist as well, it's amazing as we understand more and more about the structure of living organisms and the biochemistry that's involved, that we don't recognise that these structures are absolutely impossible to arise by random chance. And some of the things, for example, that we take for granted and are so common that, we take them for granted, and of course part of the evolution is there, all these small changes occur. But we need to always remember that these small changes are a result of changes in a molecular code. So this is a code made up of molecules, and changes in the structure of this molecular structure, in other words, rearrangement of the atoms, can produce, as a result of machinery network, ribosomes and so forth, that then use this code to assemble proteins and fats and sugars, which are the building blocks of life that living organisms get from their food. So they get the building blocks from their food, and these building blocks are then broken down into very much smaller components, and then those components then, which are become then the fundamental building blocks, are then rearranged according to the code, using little molecular machines and logic systems that assemble those pieces in the right order to make the structure. So, for example, the people next to us are building a house at the moment, and I noticed the windows were delivered quite early on. We're sitting on the concrete slab for a while, but the windows had to wait until the steel frame had arrived and actually been assembled, and the place for those windows had been made, and then the windows could be put in place. And the bricks then were also stacked up, but they couldn't be put there again until the frame was in place, so that they could be assembled around the windows and so forth. So everything had to be done in a particular order, or it wouldn't work. It wouldn't be a function. The house wouldn't function. That's a very simple organism, with or structure with very few parts, and it doesn't move and so forth. Hopefully, it doesn't move. So, when we consider this and the logic involved, it just amazes me that we're still teaching in our schools that the structures that we observe could arise by random chance. And, thinking about, okay, we get all the fundamental building blocks through our food. Well, where does our food go? Well, the first place it goes to is our mouth. And so I thought, let's have a look at the mouth and look at the amazing design features in our mouth that, again, evolutionists claim arose by blind, random changes to a code. So you could have a statement in code, the cat sat on the mat, which is, a series of letters. And then you need to make adjustments to those letters and so forth, and build new code and to add for it, and ate some food. And so even just a basic change to a code like that to build something new, if you were sitting at a typewriter and just typing random letters, right, to get the spaces in, how long do you think, just blindfolded with no knowledge of where the keyboards were, or say maybe put, sort of a 1-year-old there tapping on the keys, how long do you think it would take to add to that sentence and ate some food? And we know it would take a really, really long time for that to happen, even just that number of letters, because of the random, to assemble those components. And that's what we're trying to assume that blind random mutations could do. But the code has to be far, far more complicated, involving, not just an additional dozen or so letters and ate some food, but instead, thousands, hundreds of thousands of new letters have to be added to make any meaningful code. And so, just looking at the mouth, when we think of the mouth, we've got our lips, and they have a special structure and actually serve a number of purposes to open and close and protect the mouth, the cavity that we put the food in, and so it's flexible and they have their own muscles. And then in the mouth itself we have the salivary glands, we've got the teeth, and we've got the tongue. And then, of course, we have a couple of areas in the mouth, and one area is called the vestibule, which is the area between the teeth and the lips and the cheeks. And then we have the main oral cavity. And the oral cavity is lined with mucosa, and there's a mucous membrane that produces these special molecules of the lubricating mucus, and only a small amount is needed of that. And it's interesting that these mucous membranes vary in structure in different, and they can occur in different parts, but they all produce a lubricating mucus, which is either secreted by surface cells or by, perhaps more often, by underlying glands. Now, even just when we think about that, there's amazing structures that are involved there, membranes that all have to be constructed out of specific molecules and chemicals and have a specific porosity, in other words, to allow the mucus to pass through. And then we have to have these glands, and also all the chemical functions in the glands that actually make these particular mucus components. And for example, the main component of mucus is a glycoprotein, so it's a protein coupled with a sugar called mucin. And there's also areas of the different structures, skin structures that control these membranes and this sort of thing, have different types of elasticity. In other words, the top polymer molecules that are made have special structures that allow them to be stretched. And we have these particular layers of smooth muscle tissue that cover the inner surfaces of the lips and the floor of the mouth. Of course, also the mucin is actually highly protective against tooth decay. So we've also got the teeth. So it's interesting that this mucin has a particular chemical composition that actually helps protect against tooth decay. And then, of course, we've got the roof of the mouth, which is termed the palate. And that separates, of course, the oral cavity from the nasal cavity above it. And so the overlying surface there is covering a plate of bone. And so we have all these different types of muscle and tissue and connective tissue, and the different muscles that can move that allow us to swallow foods and liquids. But all these different structures have different codes. And so again, the evolutionary model has to assume that all these codes, right, and just like if I write APPLE, you can picture in your mind an apple, particularly if you know the English language, or if it was in French, if I wrote POOME, you'd picture an apple. And so they're codes, and you've got to have a code, a specific code. You also have to have a code reader. So, for example, if I spelt out APPLE and you were from, say, Iraq and had learnt Persian, then you wouldn't know what I'd said. You perhaps wouldn't even recognise the letters unless you'd been to an English school. So it's a specific code. In a specific language, but the letters APPLE, they don't look anything like an apple, but they are code that our mind reads, and we translate that into the image of an apple. And so there's so much, of course, there. But looking at these, and as I said, so all the codes for all these different little muscle types and connective tissue types, they all have to be in the right place. They've all got to be connected the right way. They've all got to be assembled the right way. If we had some of the connective tissue from the cheek connected to the tongue's not going to move the right way. So everything, you can't have random mutations assembling this thing. Everything has got to be assembled just right according to a plan. And I think the important point is that the plan doesn't look like anything that it is making. It's not like when you build sort of a a tiny little model of a building, an architect will build a little model of the building and then use that to get some perspectives and that to amplify the dimensions and so forth. But he builds the little model to make sure it works. This is written in a code that says, place one brick on the other and, use cement in such and such a place and run this conduit tube for this electrical and this pipe for this water and all this sort of thing. So it's a written code that would be written in English, using the word PIPE, again, which doesn't look like a pipe, but can be translated as a code by the builder that, yes, this means a piece of pipe. And we can, describe it even further. It's plastic PVC pipe of 12 mil diameter or whatever. And so, again, this 12 millimetre diameter, 12 mm diameter, is a code that the builder can read. Yes, that's a particular size. And so the same code is written with molecules that we abbreviate A, C, T and G. And we in English we've got 26 letters and 10 numerals, and so we use these combinations to describe knowledge, instructions, these sort of things, and maybe a couple of other symbols that might be used, commas and so forth, full stops. But so again, in the code, it just uses 4 letters. That are arranged in particular sequences, and they describe this operation. But then when we delve into it deeply, if we look at something like the salivary glands, for example, which are just one of the glands in our mouth, there are 3 pairs of main salivary glands, and there are between 800 and 1,000 minor salivary glands, all of which mainly serve the digestive process, but also play a part in the maintenance, as said before, of dental health, general mouth lubrication. And without mouth lubrication, for example, speech would be impossible. It's interesting, I know someone who recently had all their upper teeth removed, and they're waiting to get the dentures made. And, of course, it's very difficult for them to speak and to understand what they're saying now. And they sound, very, very different. And so, again, there's certainly the laxates here would affect our speech. And these main glands are all exocrine-type glands. They secrete via ducts. So, again, you've got to have these components in the right place. The largest of these glands, of course, is the parotoid gland that secretes serous. Then underneath the jaw, you've got the submandibular glands, and these produce both serous fluids and mucus. And there's a number of different phases here. The third pair of the sublingual glands are located underneath the tongue, and their secretions mainly mucus with a small percentage of saliva. Now, again, all these secretions are innervated by a facial nerve, and these glands also, for example, when we're chewing, there's a number of little systems that are activated then, and they begin to secrete the enzyme amylase, which, of course, will break down carbohydrates, convert starch to maltose. And so, again, we've got another series of chemical chain reactions that have to be programmed to produce the amylase and to secrete it at that particular time. Now, there are other serous glands on the surface of the tongue that encircle the taste buds on the back part of the tongue. And these produce another enzyme, lipase. And lipase is a digestive enzyme that helps split up fats. They also then serve, and it's fascinating that these glands that are sometimes called the von Ebner glands, it's been actually discovered that they have another role in that they secrete another type of chemical called histatins. And these are compounds that are antimicrobial, and they actually are our first line of defence against the microbes in food. And these seem to be released when food first makes contact with these glands on the tongue tissue. So this sensory information stimulates the secretion of the saliva, and again that helps the tongue to work and makes it much easier to swallow food. So when you think about it, this whole system is complex. We've got specific chemicals that are released there that allow for pre-digestion. Now, the traditional evolutionary model is, well, these chemicals evolved over millions of years in different organisms as we progressed on. But what we forget is that even if you have millions of years, the specifics to encode for these are so specific that when we do the maths and work out the probability of the biochemical chains, that is the series of chemistry reactions that are required to synthesise histatins and these lipases and amylases and so forth, they just don't happen. They've got to be synthesized. These molecules have to be synthesised. And if we're doing them in the laboratory, most of them are multi-step syntheses. That means they're quite complicated. We've got to do a series of reactions in order and separations and so forth. But then when we dig a little bit further into, for example, the saliva, which moistens and softens food, of course we chew the food as well, and that's released with the chewing. And of course we call that mixture of saliva and that bolus, and the bolus is further helped by the lubrication provided by the saliva, so that it makes it easier to swallow. And of course the saliva in the mouth can account for up to 30% of the initial starch digestion in starchy foods. The lipase starts work a little bit breaking down fats, but the main lipase is produced further down in the digestive tract. But as well as its role of supplying these enzymes, the saliva, of course, I mentioned earlier, has a cleaning action on the teeth and mouth, and this immunological role in supplying antibodies, and other compounds such as immunoglobulin. And again, these sort of compounds are the key in preventing infections of the salivary glands. And the saliva also contains a specific glycoprotein called haptocorrin, which is a binding protein to vitamin B12. And so it binds with that particular vitamin in order to carry it safely through the acidic content of the starch. And when it reaches the duodenum, pancreatic enzymes break down this particular glycoprotein called haptocorrin and free the vitamin, which then binds with the intrinsic factor. And I'll talk about that another time. But this is a very, very important step, Without B12, we will die. We'll get serious disease and die. And yet this vitamin would be destroyed, and our body can't synthesize B12. We have to get it from food, and that's why people that have problems with this system have to have B12 injections and so forth. Now, this is very interesting because this is a specific protein, haptocorrin, which binds to B12, right? So the body produces this particular glycoprotein in the saliva so it can bind with the B12 in the food. And also B12 is produced by bacteria living in our teeth. So these bacteria can actually process food that is there and that are living in our mouth and actually synthesise B12 as well. But it's not going to get to our body to be able to be used and absorbed unless it can be carried by this specific glycoprotein haptocorrin. So how did blind, random mutations know? What's the probability of producing a specific protein that will bind to vitamin B12 sufficiently to protect it? In other words, strong enough bonding that it's not broken down by acid in the stomach, and yet then can be broken down when it reaches the other enzymes in the dupas. Otherwise, we would die. So, to me, these are very specific factors of design. And without them, we would die. It's a very, very simple, mechanism. But if that wasn't there and that system wasn't in place. Now, the body is full of these sort of systems, and yet we continue to teach our children that these systems evolve by random, blind, chance mutations. We can do the maths and know they're absolutely impossible. Absolutely impossible for the probability of that sort of thing to occur at just the right time for these glands to producing that. I mean, what's the chance that those glands are in your toes and produce it down there? If you're going with blind random mutations, they could be produced anywhere, on your calf muscles. Why is it produced right there? So that it can be in our mouth, so it can be added to the saliva, in the part of the biochemistry of saliva. There's a lot more that we could say about saliva, and maybe I'll talk about that another time. But to me, we have this overwhelming evidence of amazing design. But not only is there amazing design, there's the systems that build it according to that design. So you can have the code, you can have the design as there encoded in what we call the DNA molecule. But it's useless without a ribosome, which is a machine that's going to read the code and then take in the basic building blocks, amino acids, and then assemble them according to the instructions in the code. And this is an amazing complex system that I think we can see, can't arise by chance. And this is why, if you're listening to this program, I'd really like to encourage you to tell other people about the programs and the talks that I've been giving, and look up the past ones as well. We have so much evidence for a creator, and we need to get the message out to young people, particularly, and to as many people as possible, that evolution is absolutely impossible. It can't account for the life on Earth. Instead, a creator, an amazing supernatural creator can, and we have the Bible describes such a being that matches all the evidence that we have, and that's in the Bible. You've been listening to Faith and Science. If you want to re-listen to these programs, remember Google 3abnaustralia.org.au and click on the radio and listen button. And again, remember to tell your friends. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.